breakthrough actually, and it's really nice. I think that maybe I might even do a tutorial on hacking this together because it's actually a really nice, easy way to get volumetrics from volume textures that just uses existing components. You get like by default you're getting like light working with the volume. We can do things like change the albedo here and then change the light color to like something else. We'll do like green and then turn that up over here. We turn the albedo gain. We can change the color of this. I've added some stuff, like I added this emissive property, which allows us to give the entire system like an overall emissive color. And then, but that's not really what you got to do. So I might do like a full feature tutorial on this, but what you're going to want is the Niagara Fluids sim, I think is where this lives. So let's find it. Um, heterogeneous. Um, heterogeneous. Am I spelling it wrong? Hetero. What? Okay, let's try it over here. Hetero. Okay, here we go. So what you're gonna want, yeah, it's Niagara fluids. You want this component, and this material. And what you're gonna want to do, like these can stay unchanged. You can clone this material. So like I cloned it into this heterogeneous volumes custom. Um, so if we go in here, this is built to sample a VDB. And so it's doing like a bunch of stuff and it's expecting a very specific formatted volume texture to sample from and things like that. But like this, the whole idea of this is that it's supposed to work from a VDB. Okay, so what is this doing effectively? Well, I don't really know what the hell blue is, but I know that R is the density sample. So what I did was I cloned the material and made this custom material. And you could even get rid of this because it's not doing anything here. But the primary thing is you want to take whatever the density channel of your volume texture. So in this case, I have my encoded volume texture, which encodes the RGB contribution from the stars or the accumulated RGB from the node in RGB, and then alpha is density. So whereas before it was doing red into density, here I'm feeding alpha into down here. And then you just sample this however you want to do it. So like in this case, I'm using a volume texture. If you're using a flip book, you would sample it however you would sample like a flip book to get a 3D texture, but any kind of sampling of 3D textures will work here. You could even do procedural noise functions if you wanted, although it would probably choke performance. You can do volume noises, various types of volume noise if you want to, whatever you want. Just know that like this input here should be like the density of your actual function. And I'm not too sure about what all this is doing because in my actual implementation, I got rid of all this for my own emissive model. Um, but yeah, so let's take a look at what that looks like. So a little bit more pared down, still a work in progress, but it's starting to get there. Um, Here's my texture sampler. I do a so when you do this with the volume textures instead of a VDB, the noise is oftentimes going to be like a coarser texture than like a full-fledged VDB. So what I do here is I have another layer of 3D noise. I think only one is enough because it really like you want to avoid, you want this step in red here to be as efficient as possible because everything you add here is basically like multiplicative on your performance. So like what we're adding here is one more sample, and even that slows it down quite a bit. And then we're using that sample as a distortion on the XYZ of the volume texture UVs with some parameters. But when you do this, it lets you basically tune these parameters to a point where you can kind of camouflage the fact that it's coming from a lower resolution texture. Um, then I feed the alpha into this extinction here, which is the density, and also get rid of this. And then also we can get rid of this. Just cleaning up stuff while I'm talking about it. Um, yeah, so I've added my own little logic for adding emissive, which I still need to kind of hash out here. And likewise, I've added my own logic to calculating the albedo. Like I've added an albedo color here instead of just a constant because we want our cloud to have like the ability to have specific colors for like a nebula. But that's really it. We just totally got rid of the emissive and temperature stuff that was in the middle here. I'm only using the extinction and plug it into some like I'm still working on this part. But the end result is really really nice, and it's probably what I'm going to end up using for my procedural uh, volumetric volumetrics of just like all varieties because it's performant. It looks good. It just automatically gets a lot of the logic and cool stuff that I was having to like meticulously code by hand in the Ray Marcher. And it doesn't have as much artifacts as the Ray Marcher in like weirdness. So really, I think this is probably the way to go for a custom volumetric cloud like this. Getting the lights working with it for free is really nice too. It's just like it just works, which is really kind of cool. We could also, for instance, grab our directional light. Here we go. Let's change this to white. And you can immediately see that the directional light's also having an effect on it. Oh, source angle is not what I'm looking for. You can see it affects the shadows as we kind of spin this around. So yeah, it's very nice. Like I like this a lot. It's probably going to be what I end up using, and you can see the distortion effect here. It's probably like I mean you still have some issues. Like it's not completely done yet. I still need a camera distance fade so that when things get like right up on the camera, we can fade them out, and that will kind of get rid of some of these distortion artifacts that you can see when you're really close. Because like if you're far away, it looks fine. You get a little close, it looks a little chunked up. But that would just be basically figuring out how to go into that logic and add like a camera fade out to it. But I am pretty happy with this approach. So this density field was generated from like the octree of a generated universe. So like we can generate a universe and then generate a volume texture at either 128 or 256 by 256 by 256. And then we can load that generated volume texture. Let's find a 128 one. Here's one at 128. You can load that into this component, which looks like it needs its bounds extended a little bit. Um, I'm sure I'll need to do a little bit more work on the component too because this has got stuff that is just not needed anymore. The heterogeneous volume component. Where's my... Hold on. Great, we're back. So this guy has a scaling factor somewhere. Yeah, here it is. Volume resolution. And so if we need more space like on the z-axis here, we can kind of chop it to where we need it. Obviously, this stuff has to be hashed out because I don't want to have to be like manually determining where this stuff gets cropped at. We have our texture. It should be easy enough to derive this information. I just have to figure out how to do it. But like the initial results of this are very promising, pretty cool. Um, you can have multiples in a scene. Let's see. And I mean, like if you're putting multiples of these, they are going to have a performance impact. It's not a silver bullet, but believe it or not, this is actually faster than the. Um, this is actually faster than the Ray Marcher was running, so that's nice actually. And the fact that it gets lighting influence is just like kind of a cherry on top because it makes it really easy to do something like, what if there was a really bright star in the middle of this cloud? Then maybe it would have, you know, I don't know, 16,000 candles. And it'll just light up the cloud however we want it. 16,000 might be a bit much. Maybe we'll just go with 1,600. And as long as that light overlapped like a star, then it's going to look like a star nestled in a dust cloud, which is just really, really cool, I think. All right, so we don't need three of these. I mean, in practice, we would probably only ever run 1 to 2. You might have, so no, there would be 2. So I would run 1 for the overall universe, and then 1 for like galaxies that you get, or nebula that you get close to. But it's just really cool. I thought this was really nifty. I'm going to be kind of refining this material over the next few days to get it ready to be proceduralized, and probably also refining the heterogeneity. I'll probably make a clone of this because I want my volume resolution to be derived. I don't want to have to manually set it. Things like pivot at centroid should just be auto checked. This may be doing things like with animation that I don't need, so I could rip all that out. Anything having to do with setting like a VDB, I can rip that out. Because so and the nice thing about this is like you could already use this for VDBs. This is what they use for that. Um, this allows you to use the thing that they were using for VDBs with volume and flipbook volume textures. I don't know how to procedurally generate a VDB. I'm sure it's possible, but I do know how to procedurally generate a volume texture or a volume flipbook texture. So instead of having to like figure out an arcane data format, I can just output, a texture the way I want it, and use that as my volumetric, which is just really, really nice. So yeah, I thought this was cool. I mean, we have all kinds of controls here as well that I haven't really talked about. Eventually, when I'm satisfied with this nebula texture, I might do a tutorial on it. Um, since I do think the idea of like kind of hacking this VDB flow for displaying volumetrics is really powerful and really easy, actually. Way easier than writing a ray marcher. So yeah, I mean, this is, like I said, this is still needs work. I want some kind of balance between the two here, like the albedo gain and the um, emissive. Like I want to be able to have glowing clouds. I want to be able to have glowing nebula. I want to be able to change the patterns of the glow. So what it probably end up being is I will have two emissive components, one for the shadow, one for the one for the parts that are in shadow, one for the parts that are in light, and then just ambient the way it is, and that would be like um, enough to do what I want to do with it. I think you can also see here that it actually doesn't look super pixelated. Excuse me, super pixelated and blocky, and that's because we have distortion, like I was saying, because we're using something that is a quote unquote lower quality than a VDB, but it has the benefit of us being able to proceduralize it at runtime. Um, we need this distortion noise to kind of hide the fact that this is very low res. So this is what it looks like without the distortion noise. It's basically the voxel density field from our octree. Um, and you can see like it's pretty chunky and pixelated with lots of square artifacts and such. But then if we were to just go in here to distortion amount and change it to say like a 0.05, all of a sudden it doesn't look so bad anymore. So we're kind of like harnessing our octree data to kind of lay out the basic and block out the basic volume of the noise, and then leveraging another layer of 3D noise to kind of jitter the octree volume in a way that makes it not look like it's made out of 8 by 8 pixel blocks. But yeah, so I'm going to be messing with this more in the next few days, so more to come. I just thought I would show this off because I thought it was really cool. Really neat effect here. No, 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 not that one. I want to copy. I'll show you something else. This is not restricted to a single light or like a single light color. We can do whatever we want with it. Angry red. And via like manipulating this with different lights, it's cool because like if we spun in like a point light for a star in our system, then it could light the gas around it, which is just really fucking neat. Honestly, it's really super duper cool. So yeah, that's probably it for now. Um, I got some stuff I gotta do this afternoon. I need to go shopping and such. Maybe tonight I'll sit and play with this some, because obviously I still need to gain full control over this material. It's kind of just something I hacked together yesterday afternoon and was pretty happy with. Um, but yeah, I'm going to be messing with this for the next few days, trying to get it to a usable nebula slash gas generator asset. And oh, I forgot, like, because this is coming from a texture, I mean, you could do this with VDBs too, but getting the VDBs at runtime, we can actually use different volumes here and get different effects, which is really, really nifty. Oh, yeah, here we go. This would be like one of the galaxies I think I sampled into the volume. So, like, you could imagine a disk or a spiral of stars overlaid on this gas disk, and that would be like your galaxy nebula. That's going to still need work because the galaxy occupies a much smaller percentage of the overall voxel than the universe does. So the universe actually gets the benefit of a higher resolution because of that. Oh, here's one. But I think it's still probably usable, and there might be ways that we could optimize it to get a higher resolution. Like, um, we could sample it in like a stretched format or something like that to get higher Z resolution. I don't know. There's still work to be done there. What else? What else? What else? What else? Change this if we wanted to glow without it, or some blend of the two, which I think looks best. Uh, Change the emissive color here. Change the albedo color here. And the albedo color will also take over more if it's more in light or if we add more albedo gain. And likewise, the emissive will take over if we multiply the M. But like these values are not properly configured yet. Like I want more discrete control over it and less um, interaction between the two different values. Like, but that's what I'm gonna be doing the next few days anyway. So it should be fun to figure out and just kind of mess around with this thing. It's pretty nifty. We also need to make the distortion noise available as a parameter because changing the distortion noise here also will substantially alter the appearance of it. So like here it is. You can kind of see the distortion patterns here. I'm using, I think I'm using Perlin Whirly right now. No, this is with Voronoi. Um, if I use Perlin Whirly, we get a completely different distortion effect. So yeah, we could like you could change like the appearance quite a bit with just this one parameter being proceduralized. So that's always good. I could do like gradient gradient turbulence. There you go. It's different. Gradient. And this just controls like the basically the noise driven jitter of the samples. Pretty neat though. I was impressed with how nice this was. All right, later.